All right, periodic functions. It says if a function y equals ft is periodic, that means there exists a positive real number of c such that if you added it, you get the same exact equation. Now, I want you to think back to transformations. This is happening on the inside. So HIVO tells me inside is horizontal. Now, this would technically shift left because it's pot backwards. But here's what I want you to say is we have a function, and whatever that function looks like, let's say it's like the sine curve. The sine curve is periodic because you could shift it left and get the exact same function. What do I mean by that? Instead of looking at it here, and truthfully this should go on the same way as well. So let me connect it. Okay, what would happen is if you took this, let me try this one more time, clone. If I took this and shifted it left, I should still get the same exact graph. So if I took this and shifted it this way, I should still get the same thing. Now, obviously my drawing's a little off, so it doesn't work. But if you took that and shifted it left, a period, you'd see that the graph would look exactly the same. That's the concept. That means period. So it's if a function repeats itself after a certain amount of time, it's a period. Think about anatomy. You've heard of period before. All it just means is the body repeats itself after a certain amount of time. So how can we use that for this? If we had to find the cosine of 9 pi over 4, notice this is greater than 2 pi. That means it's over one whole circle. That will be the equivalent of where it was located if you took away 2 pi, or if you took away the amount of one full unit circle. So this is the same thing as cosine of 9 pi over 4 minus 2 pi, which is a full circle, or a full period. So if I subtracted 8 pi over 4, which that is the period of 2 pi, what do I get? I would get cosine of pi over 4. This one happens to be equal to its reference angle. So what is cosine of pi over 4? Well, using the hand trick, you look at pi over 4 is your middle finger, take it, bend it, flip your hand, take it, bend it, flip it. Cosine, psi y, cos x. Tangent is y over x. X is in the bottom. You have 2 fingers down there, and it's always divided by 2. That would be your answer here. Let's try another. Sine of 300. Again, what's coterminal with this? You could just add 360, and you find out that this is the same thing as sine of positive 60. So coterminal periods, they all work in the same way. Sine of 60 degrees, look at your hand. 60 belongs to, it's like your index finger. So you take it, you bend it, you flip it. Psi y cos x, tangent is y over x. Y is on top. So sine, you have 3 fingers on top. And then the hypotenuse is always 2 in this situation. So we would have 3 pi over 2. This is in the first quadrant, so this is positive, just like the previous problem. Here's another one. So let's first figure out what this is equivalent to. So tangent of 29 pi over 6. Well, that's way more than 2 pi, so let's take away. So we take away, it would be 12 pi over 6. That's taking away 1 period. And what do we get when we get that? I'm left with tangent of 17 pi over 6. Again, that's greater than 2 pi. So just think about it. It couldn't follow the rules. It's not a times 2 minus 1, anything like that. So I take away another 12 pi over 6. And this would be equivalent to 5 pi over 6. Now, which quadrant is this? This is a minus 1. So this would be quadrant 2, which all students take calculus. Tangent is negative here. Now this is negative because it's a minus 1. If you look over here, that's how I'm getting that it's second quadrant, is it's minus 1 from the numerator to the denominator. So it's going to be negative. So what is tangent of pi over 6, the reference angle? Tangent of pi over 6, okay, our pi over 6 finger looking at our hand, the left hand, seeing the palm, we go from pi over 2, pi over 3, pi over 4, pi over 6 is our ring finger. So we take it, we bend it, we flip it. Psi y cos x, tangent is y over x. So I take the fingers on top, which is 1, divided by fingers on the denominator, which is 3. And then you take the square root of the fingers, always square root of fingers. This could reduce to be 1 over square root of 3. We don't leave the square root in the denominator, so it actually need to multiply by square root of 3 over square root of 3. So I'm left with square root of 3 for the numerator, and the denominator is 3. The answer needs to be negative, so I put a negative there. That's my answer. If you want to check in the calculator, go ahead, type that in, type these in. You'll see that they're exact match. That's using the hand trick and the AST trick. Now you try this one.